How does a computer compute a result? The task might seem easy enough, just add two numbers and let the magic happen. What you don't know is how the CPU uses the data we provide to calculate the result of the operation. Computers don't understand human language. That's why the addition instruction needs to be converted into binary. To understand what exactly happens, you need to understand. Binary is not as simple as base 10 numbers, which contains 10 numbers 0 to 9, that is base 10. But binary is base 2, which has only two digits 0 and 1. In a very sciencey way, the scientists figure out how to convert them from decimal to binary. Take this number for example. Each digit is called a bit. Each group of 2 bits is a crumb and a group of 4 bits is a nib. Now to understand binary, you need to check all digits from right to left and label them in rows. So the first digit here for example is 0, which comes in label group 1. Then start doubling the digit for labels. Next is 2, the double of 2 is 4, the double of 4 is 8, and so on. The bits under labels 2 and 8 are 1, so add 8 and 2 and there it is. Decimal for 1010 is 10. Similarly, you can get the decimal form of any binary using the same method. You can also convert decimal to binary, which is what a computer does in the background. For example, we will convert 14 to binary.
First, we will divide the number by the base that we need to convert the number into. For example, here it is 2. Now get the remainder and add it onto the stack. We will repeat this process until we get the remainder as 1 and then flip all the bits to get the remainder.
And you have the binary for 14. Enough of binary chit chat. To understand what computers do while adding these two numbers is convert them into binary and add them. But how do computers add them? What a nice way to segment into. Now, as we have discussed how binary works, let's add them. Let's take a new example and add 4 and 5. So 4's binary is 0100 and 5 is 0101. Now to add them, we just arrange them like normal addition, but the addition of each bit. First addition is 0 plus 1 is 1, 0 plus 0 is 0, and 1 plus 1 is 2, which does not exist in binary. For adding 1 and 1, we need to understand the rules of binary addition. So in binary addition, everything is similar to decimal addition except 1 plus 1. In decimal addition, 1 plus 1 is 2, and in binary addition 1 plus 1 is 0 and carry 1. Now we can take a look at the example again. We know 1 plus 1 gives 0 and 1 carry. Now 0 plus 0 gives 1, so the binary of addition of 4 and 5 is 9, which is the same result as you did the decimal addition. Magic. Let me clarify, we haven't even scratched the surface of what digital computing looks like. It's a whole world separate from here, and if you want to learn more, hope this was a good enough starting point for getting into the world of low level computing. Thanks for watching. We'll meet in the next one. So subscribe, cause I don't know when I'll post a new one.